Okay, so inside a vector space, we sometimes have what's called a subspace, which has a very specific definition given here. Okay, three main things. To be a subspace, you have to, you have to be a subset. That's maybe the first thing. Okay, then there's three properties. You have to contain the zero vector. You have closure under addition and closure under scalar multiplication. These are the criteria. Just to remind you what a scalar is. So pause and copy if you haven't already. Everything here. Now, important remark. Okay, you can prove that H in this case is itself. It is itself a vector space that is sitting inside of V. Okay, so that comes up from time to time. Okay, and you can prove that basically H passes all the axioms, 1 through 10. Okie doke. All very abstract. So let's actually go into the world of actual houses. We'll think about R2, and then we'll let H be a line through the origin. Now, I've written this H three different ways. So I would like you to make sure you understand this equal sign and make sure you understand this one. This notation is not going to go away. So before we go too much further, please ask me during class to explain those if need be. Okay, so the question here is H a subspace of V, which is R2 in this case. So how am I going to answer that question? Well, I'm going to go through A, B, and C. It's A, B, and C, right? Yeah, A, B, and C. So I'll say, let's check. Okay, first, H is a subset of V, right? That's obvious. Since, visually you have R2, and then you have, let's say 2 is here and 1 is here. So you have your line going through the origin and going through the point 1, 2. So clearly, H is inside of all of R2. Okay, now we'll go through ABC. A is the zero vector in H. Well, the answer here is yes, right? You can see it here. But we should get used to writing these things down. Yes. Why is that? Because 0, 0 is in H since, well, it passes the, you can use whichever, I think maybe use this one. This is the kind of the test you have to pass in order to get into H. Okay, this is what I have to check. Okay. Since, 0, since x equals 0, y is equal to 0. So 0 does indeed equal. So, no, it's right like this. So y does indeed equal 2x. Yeah. So I'm writing almost more than I have to. Okay, so when I stop writing, this is very important. When I stop writing, I should look at what I wrote and ask myself, someone who is not me reading this, can they follow? Is there a linear argument here? Here I state the question, I give my answer, and then I produce a rock solid demonstration. I show that this vector passes this test. It's important to practice writing things down. If it's not on the paper, then I cannot read your mind. I will not read your mind. I will mark what's on the paper. B, close under addition. So what do I need to prove here? I need to prove that if I have two vectors that are on this line, well, you can see it, right? You can see if I have a vector here and say a vector here, and I add them, I'm going to end up, still on the line somewhere, right? Okay, that's all fine and good, but how can I write a demonstration? Well, what I'm going to do is I'm going to say, imagine you have two vectors that are in H. Maybe in H and say CD, B and H. What do I need to do? I need to prove that when I add these two things, I'm still in H. So I need to show, NTS, need to show. What do I need to show? A plus C, B plus D. This is what I need to show. And my proof, well, I'm going to write this out in all detail. A, B is an H. So what does that tell me? It tells me that B is equal to 2A. How do I know this? Well, AB is an H. Okay, to be an H, you have to pass that test right there. Okay, your second component has to be twice your first. Okay, my second component must be twice my first component. CD is also an H, so second component is twice the first. Thus, remember now, okay, now I'm deep in my demonstration. I want to remember what I'm trying to do. I'm trying to prove this. So what I need to prove is that the second component is twice the first. So B plus D is, well, B is 2A, D is 2C, factor the 2, and I am done. So A plus C, B plus D is indeed in H. Put a little, oops, put a period first. Okay. Okay, there we go. Okay, I did a lot of writing, okay, but it's not necessarily a bad thing. You want to be as clear as possible. This is useful. Tell your reader what you're trying to do, and then do it. Part C. I'm going to prove that need to show that no, let's start over here. Let's go. Let C be a real number. And let AB be in H. Now I'll do my NTS. I need to show that C, CACB, this scalar multiple, is still in H. I don't escape H. Proof. I'll do what I did before. AB is in H, so the second component is twice the first. Thus, CB is equal to C times 2A. Just do it very tediously here. So this calculation, expand it, the more, let's be careful here. Try to be as clear as possible, let's say. More is not always better, but clarity is what we're going for. So this item up here is in H. How do I know it's in H? Because I've proven right here that the second component is twice the first component. Okay, so I've proven A, B, and C. Therefore, H is a subspace of V.